Using cold plasma or high voltage electrical charges on seeds to improve germination, tackle fungal pathogens and boost yields is an intriguing new field in agtech. But is it ready for prime time?
Plasma is complex, and the mechanisms we were talking about, they are complex too, and because of that we are still understanding a lot of things, but there is a lot proven already. We have 5 seasons working in the field demonstrating the yield improvement, the pathogen control effects, so we can already say that this is ready for commercialization. This is ready in terms of the implementation of the technology and the compatibility with other treatments for seeds. But yeah, it's not a well-established technology because the industry is not yet using it as we want to. So there are many teams, companies, and also researchers working on non-thermal plasma technologies. What I would say is we have the biggest plasma reactor to treat seeds in the world, and that's why we unlocked the most challenging part of scaling this technology. We can build a reactor that works continuously, and it could be integrated in the industry, and that's also why we are targeting broad acre crops, open field crops like soybean, corn, barley, wheat, and not focusing on specialty crops. Our technology was created inside the academic ecosystem. My co-founders have been working on this for 15 years. So we are in licensing the technology from the universities where they created this technology. And also our IP is based on the know-how on what you mentioned. How to treat the seed depends on the recipe. We are creating different plasmas, and you need to understand that some plasmas will be great for that seed and some plasmas can kill the embryo. And because of that, the most important part is not just the plasma reactor, that is the patented part of the technology, but also the right recipe to generate the effect you want to generate.
So how transferable is it then? So if you've got something that's working quite effectively on one seed variety, if you then try and achieve the same results with another?
Implementing a new species or a new variety could be a challenge or not, depending on the difference between the one you know and the one that you are starting to work with. And it's not just limited to the seed, the variety, or the species, but also the ecosystem around that seed. Are you planting that seed in a different ecosystem? Are there new pathogens involved? So it depends again, but it is transferable. While you have more data, you will be able to fine-tune the recipe faster. And that's why it took us 5 years to develop the first right recipe, and now in a few months we can have a new recipe for a new variety with a new application. So it's getting better, and today everything is about data. If you have enough data, then you can do the process more efficiently. Most of the challenges we are trying to solve or solving with plasma already are related to seed quality. And something amazing about this industry is that we already have a lot of protocols to measure seed quality in the lab. And depending on the seed, it can take a few days just to measure seed quality in terms of germination, in terms of pathogen presence, that kind of variables, we can measure them in a few days in the lab. So because of that, the treatment could be first validated in the lab in a few days, and then if you want also to validate the yield improvement in the field, then you go to the field. But the first process, which is the most challenging one in terms of the amount of plasma treatments you need to validate to see what is actually happening to the seed, you can do it in the lab.
So what is your business model? How and where does the technology fit into the supply chain?
So our technology is targeting seed companies in the broad acre crop space, and because of that, we're talking about tons and tons of seeds per hour processed. There's no way to offer the service to these companies because logistics will kill the math behind the business, And because of that, the only way is to install our equipment in the middle of the process and be part of that process and not a bottleneck. That being said, we are basically designing a fee per ton business model where the seed company or the seed processor pays us depending on the amount of seeds they are trading.
What is the ROI for the customer?
Each seed we are working with has a different value in the market. So because of that, calculating or simplifying the ROI, it's really hard, but I would give you an example. So one specific problem we're targeting is seed dormancy. Seed dormancy is a physiological evolution in nature. Is amazing. That's the way species survive in nature. But in the industry, it's a challenge because some seeds, when you harvest them, they are not ready to germinate, and you just need to wait. There's no solution in the industry for that. And for one of our clients, that represents $1 million per year.
Right.
Right?
Yes.
So that's a huge problem that doesn't have a solution yet. And with our technology, we can solve it in 3 times less time than just waiting. And because of that, we can charge them $2 per bag we are treating, and they are avoiding $1 million losses. So that's kind of the ROI you can calculate.
In terms of fungal pathogens, obviously seeds can be a vector for those, but they're also in the soils.
Considering the effects of plasma related to pathogens has 2 different aspects to take into consideration. The first one is the pathogens that were in the seed when we treated them. We can control those pathogens, so that's a very important part. And some of the biggest challenges in terms of pathogens are already in the seed when you harvest them, like Fusarium, Phomopsis. They are all in like seedborne pathogens, right? But then you have these pathogens that are in the field. And what we can offer is first a combination with chemicals or different biological treatments for that, because our technology is compatible with all of them. So that's a very important factor. We can reduce the use of them, but we can also be part of the same process and collaborate with those. So we have very good synergy with other treatments. And the second part of the answer will be that we are also acting as a priming process. And that priming process involves preparing the seed better for stressors and pathogens in the field. So we are not going to eliminate or control the pathogen in the field, but we are preparing that seed to be a better plant in the field and to defend itself better. So it's kind of an interesting option too, but I would recommend to complement the technology with a different one, with another treatment, as producers are already doing. And that's an important cultural part of this business. This will not replace chemicals tomorrow. That's not the way it will happen. And because of that, we really need to validate the complementary effect between our technology and the rest of the seed treatments.
What about regulation? How do regulators regard this technology?
When you talk about regulations in our space, you need to consider 3 questions. The first one is, what are you claiming to generate with the technology? The second one will be, are you generating any kind of residue in the seed you're treating? And the third one will be, are you genetically modifying the seed? And the answer is, the first one, it depends. If you are considering this technology as a pesticide, then you move forward with the second and the third question. And in both cases, the answer is no. We don't generate any residue, and we don't modify the genome of the seed. And because of that, there is no regulations, but just the manufacturing practices we need to consider as a manufacturer. So I would say our biggest milestones so far has been first creating the most scalable plasma reactor for this kind of seed treatment. That's important. And we're targeting tons per hour seed processor next year. So that's a big challenge, but also a big achievement so far. And the second one will be, we are running today 7 active pilots with potential customers that are validating the technology, which means a lot because this is pretty new technology, and they are trying to understand the benefits and the challenges and what involves to work with this technology. So 7 active pilots today, targeting 10 for the end of this year, and we are collaborating with the 4 principal crops in the industry: corn, sunflower, soybean, and wheat, and also including barley, because we are collaborating with malters, not only seed companies. So that's another application, an interesting application for the technology.
So what's the potential benefit with malters then?
With malting, well, I mentioned we are really good at germinating seeds. And malting is basically germinating barley seeds or other seeds, but so we can accelerate the water absorption process, what they call steeping, and we can accelerate the germination process too. So we are basically trying to improve the productivity of their facilities.
So you can shorten the steeping times.
Exactly. The steeping time, the germination time, and the water usage. I would say that the biggest challenge as a company working in the plasma space is that some seed companies already tried to implement plasma and they didn't have a good experience. what I have to say about that is that if you try plasma, it's like saying I tried tea and I didn't like it. What about the rest of the liquids, right? And because of that, you can't consider that you tried plasma if you tried once and it wasn't a successful process. You need to try more, and because of that, the first process when you are onboarding a new client is to do a screening of different treatments, and you need to be patient with that first process to achieve the right results you want. So being very clear, the challenge is for the people to understand that plasma is a state of matter, and there is no way you tried all the plasmas to demonstrate that that's not possible or a solution for your seed. You need to move forward and try different plasmas until you find the right one.